Hello, students. I am in my kitchen ready to have my lunch today. And I was thinking, hey, why not take advantage of this opportunity to help you complete your classroom activity for this week? So, if you haven't done so already, turn to page 122 in your book, the classroom activity. Although I'm not going to use any flowers today, I am going to use a couple of fruit. So I want you to watch what I'm doing and then use your observations to try to draw what you see and come up with a conclusion. Remember, this week we've been talking about angiosperms and gymnosperms and monocots and dicots. Make sure you read over the problem of the classroom activity before you begin. And then once you've written your hypothesis, check out these observations. I have two fruit here. I've got an apple and I've got a banana. Let's start with the apple. I think apples are yummy and delicious, and they're good for you too. But have any of you ever cut an apple to eat it? Maybe you slice your apple up and down, or maybe you have an apple slicer to get rid of the core. Maybe some of you peel an apple and eat slices off like that. But have any of you ever cut an apple perpendicular to the core? The core goes from the stem to the bottom of the apple. The core is where the seeds are found. And if you recall our lesson from this week, an apple, called a fruit, is the ripened ovary around the seeds. Have any of you ever cut an apple perpendicular to the core? If you haven't, I'm going to do it for you right now, and I'm going to show you what you see. And after you see what's inside, you might be surprised if you've never seen it before, and it's going to help you determine whether an apple is a monocot or a dicot. So let's check it out. Again, I am cutting my apple perpendicular to the core. I've cut it perpendicular to the core. I'm going to open it up this way, and let's see what we see inside. Whoa, check this out. Have you ever seen the star inside the apple? Look at the pattern. Draw that pattern and use that pattern to predict. You don't even have to predict. You can conclude as to whether an apple is an example of a monocot or dicot. Use your notes from this week to help you out. But hey, let's not stop with an apple. As cool as the apple might be, let's also try a banana. So I'm going to take a banana here, and I'm also going to cut it perpendicular to the fruit to see what's inside. Let's see if we can examine some type of a pattern. So here we go. I'm cutting it perpendicular. And if you've ever peeled a banana, I'm sure you have an idea of what we're going to see in terms of its symmetry. But let's look at the cross section. Get a good close look at that cross section and see if you can observe enough to determine whether a banana is a monocot or a dicot plant. Now that I've done a banana and an apple for you, if you're home, why don't you check out some fruit of your own? Don't cut them along the core, cut them perpendicular so that you can see that pattern inside that reveals the mystery, the solution to the mystery as to whether it is a monocot or dicot. And by the way, to prove your prediction, remove a seed and examine it and see if you can tell the difference. So until next time, you have some fun with fruit today. And if you happen to have any flowers around the house, feel free to count the petals too. Bye bye.